Hi. This is a Nimbus Commerce, a full stack cloud native e-commerce platform built using Spring Boot, Microservices, and Next.js frontend. The system demonstrates the real-world distributed systems pattern, including the API gateway with centralized security or authentication using Keycloak, event-driven communication with Kafka, Redis-based rate limiting circuit breaker, and Redis retries using resilience 4G, and real-time notification using WebSocket. Let me walk you through the architecture first. So here's the architecture. Let's okay. So the system is designed as a layered microservice architecture. We got client layer, Redux toolkit for state management. At the top, we have Next.js frontend, which uses Redux toolkit, Keycloak for authentication, and Storm WebSocket client for real-time updates. Now we got the SBO. All client requests goes to the API gateway, which is responsible for JWT authentication, rate limiting using Redis, client breaking, circuit breaking, and routing requests to the backend service. Now we got platform layer over here. So the platform layer includes Eureka service discovery, where all servers register themselves, Spring Cloud config server, which provides centralized configuration, Keycloak, which act as a entity provider. Then we've got service layer. Service layer, the system consists of four core microservices: product service for catalog inventory, user service for user management and auto provisioning, order service for cart and order processing. Then got notification service for real-time updates. Now let's go to event streaming. Here's the event streaming. Service consume communicate asynchronously using Kafka, where events like order creations are published and consumed by multiple services, consumed by notification and product service. Now we got infrastructure layer. So the infrastructure layer supporting infrastructure include Redis for rate limiting, PostgreSQL for database per service. This follows database per service pattern, ensuring proper isolation. Now let's see how everything runs together. So uh, the entire system run using Docker Compose, including PostgreSQL database, Keycloak. We got Kafka without zero people using Kgraph, and Redis for rate limiting, and pgadmin for database inspection. Now let's see the login flow. Here's the application. So let's log in. So authentication is handled using Keycloak with over 2 PKCE flow. Once the user logs in, Keycloak issues a GW token which is sent with every request. Let's log in. So the API gateway validates the GW token on every request and extract the role from the token to enforce authorization. Here's the drop down. You can see username, emails, and their orders. Let's log out. So let's see for the admin how the drop down we see for the admin page. So when you log in as an admin, you see that you are admin, and we got the admin panel for admin user. Admin receives additional permissions such as managing product. Now, this is the product page. Products are served by product service, which expose a REST API behind the gateway. Here's the user service, product service, which is served behind the gateway route to LP. Now, Product data is stored in a dedicated PostgreSQL database and uses soft delete strategy to avoid permanently removing the catalog items. Now let's add the product to the cart. Let's add it. Now we added two items. Now um, when the user add the items to the cart, the order service validates the stock availability by calling the product service. So whenever we add the cart is in the order service and it in communicate internally with our product service to validate if it is have product in the stock. Now let's uh, place the order. When we place the order service validate the card, retrieve the user profile, save the order in the database, and publish an event to Kafka. Because of this event, we are seeing the notification which we received from WebSocket. Let's see order through the diagram how the order is processed. So let's see over here. Okay. So we got this. Let's hit posting some ticket. So we got the user service. Oh, my order processing flow. So this diagram shows the complete order processing flow when the user places the order. Mm, an order go order the when the user places the order through the front end, which goes through the API gateway to the order service. Selection. Okay, we got the service over here. Go to the order service. So the order service first validate it, read the stock with the product service, and retrieve the user details from the order service from the user service. So it is validating over here and get the user information. Then once validated, the order is saved in the database, the cart is cleared, and after that the order service publishes an order created event in the Kafka. Um, the event is consumed by multiple services in parallel. This is event driven pattern allows the service to react independently without tight coupling. The product service consumes the event and updates the inventory, mm, and the notification service consumes the same event and send a real-time notification to the users. Now let's see this in the action. So again, let's add to the cart. Let's add this um, Samsung Galaxy. Go to the cart. Let's buy now. When you place the order, as soon as the order event is created or event is published to Kafka, the notification service processes the event and pushes the message to the browser being stomped over WebSocket. Here you see the notification. When you click on it, notification links directly to the order detail page where you can see the order details, what you have ordered. Now let's view the admin. Okay, we are already admin, so let's go to the admin panel. Let's So product management endpoints are protected with role-based control using pre-authorized using so here you see we have pre-authorized uh, set for the APIs where if the user has admin rules, then only it is allowed or it will show not authorized. So let's add the product. Mm, mm, Price 599.50. Let's leave it. We have added the product here. You can see Tesla L20. And now let's go to the product page. So you see Tesla L20, it is over here. You can add it and update it. Let's edit it. Mm, we have a panel, edit this, and let's say we want to update the stock of this to 10. Now delete the stock. Now the stock is updated. Now we can also delete it as well. So let's delete this one, Apple S2. So product deleted successfully. We got the toast, and here you can see we do not find it anywhere over here. So yep, all the request still goes to the API gateway, which validates the JWT token before forwarding them to the service. Okay. So so this project demonstrates the production grade microservice architecture with Spring Boot, microservices, Spring Cloud Gateway, Eureka Service Discovery. Here is the service discovery. So this is the Eureka where the all services are registered. You can see gateway, notification, order, product service, and user service. Centralized configuration with config server, Kafka event-driven architecture, Redis for rate limiting, resilience 4J for circuit breaking, and real-time WebSocket communication. This entire system is containerized and run using Docker Compose with a modern Next.js frontend. Thank you for watching.